Hello students, and welcome to another video. Today we're going to be discussing reactions and aqueous solutions. Okay, of all the equations we've been working with over the last couple of videos, of the five, the one that we're focusing on here is the double replacement reactions. All right, we're going to be looking at a problem here, and this is what the reaction we're going to be focusing on. We're going to have silver nitrate, and it's aqueous, meaning that they are dissociated in solution, and we have NaCl, and it's aqueous, but they're separated. So we have two different beakers, and they're just these clear solutions. And when we combine them, they form a silver chloride solid and a sodium nitrate aqueous solution. So the sodium and nitrate ions are going to stay in solution while the silver and the chlorine react to form a solid. Okay, and let's look at it down here. So we've got a beaker, and this is the beaker showing both chemicals combined. So we have these nitrate ions, silver ions, sodium ions, and chlorine ions. Okay, these were part of that first part of the equation right here. They're dissolved in solution. And then we've got the nitrate and the silver, which is right here, and it's dissolved in the solution. Okay, so they're all dissolved together. Now, is there any new reactions going to be forming? That's the question, and that's what brings us to the rules of solubility, okay? And on the back side of this gray sheet you'll get in class, they're laminated, okay? They're made for your tests and when you work in the lab, so if you get them dirty, you can clean them up, okay? And these rules here tell us if something is going to be soluble or insoluble, okay? And in this example, we have AgCl, sodium chloride, and sodium nitrate. Now, we can start picking apart the rules to figure out which one of these goes into a solid. Because if you didn't have the S or the AQ there, you would be like, okay, which one is a solid? Well, let's come down here to the rules. The first one is silver chloride, so let's look for chlorine. Okay, there's chlorine. Chloride salts, so it's forming a salt with silver, but it's soluble, right? And in the problem, it says it's a solid. But if we look at the exceptions, it says that with compounds of silver. Oh, wait, well, silver's compounded or made a bond with chlorine, so it's going to be a solid, okay? It's going to be insoluble. It's going to fall out of solution. So that assumes that sodium and nitrate are both going to be aqueous. So right here we have sodium, and it's soluble with very few exceptions, and nitrate is soluble with very few exceptions. So basically we know that this is going to be in solution still. It's not going to combine to form a solid, but this will because it's insoluble. All right, now let's see in the next page, it's going to show us that reaction. So we've had this clear solution being dropped into another clear solution, and the silver and the chlorine start reacting, and they form this gray, silvery precipitate, okay? And that's what we call that solid that falls out of solution, okay, a precipitate. Now, let's break down this problem and understand it in a little bit more comprehensive way. Now you see these three yellow boxes, those are the vocabulary words I expect you to know. All right, so the first one is the complete ionic equation. So if you need to pause it to write these down, go ahead, and then we'll discuss it, okay? So the complete ionic equation shows dissolved ionic compounds as dissociated free ions. So we're breaking apart the problem into smaller pieces that we can understand. So the silver and the nitrate are separated. We have a positive silver and a negative nitrate ion because their ions are atoms or molecules with a charge, okay? And then sodium and chlorine are also aqueous. They're separated from each other. They're not really forming a bond. They're separated with a solvation shell around them. And they're all aqueous. You can see what state of matter they're in. Additionally, you'll notice that the metals are the ones that give. They're the ones that give electrons, so they're going to be positive. And the takers are the chlorine and the NO3, which are all nonmetals. So that's a trend you should recognize, okay, from this year. In the precipitate that forms is silver chloride. We know that. It's going to form a bond. Okay, it's going to be insoluble. It's going to fall out of solution. And sodium and nitrate are going to stay out of solution. So let's look down here at what a spectator ion is. Is similar to a spectator, an ion that appears on both sides of the equation and is not directly involved in the reaction. So we have sodium, sodium. It looks exact same on both sides. We have NO3 and NO3. So what we're going to do is we're just going to cross those out. And we're going to call them spectator ions, and they're not important to the reaction because they're not part of the reaction. They're just spectating. They're just hanging out and watching it happen, okay? Now, if we come down here, this is going to show us the net ionic equation. The net ionic equation is an equation for a reaction in a solution that shows only those particles that are directly involved in the chemical change. So silver and chlorine were the only ones in this this complete ionic equation to be part of creating silver chloride. So we write them out as aqueous, and then we write it as a solid. This shows us what is going to precipitate out of the two solutions, okay? Instead of looking at this and wondering what is happening, if you know what the two solutions are, you can predict what this solution will be based on solubility rules. And I do not expect you to remember them, but they are on the back side of this gray sheet that we'll be using in class, okay? So keep that in mind. Thanks for watching. Until next time.